So this will be equal to 1/4 b1 plus b2. Now this is going to be a bit of a trick, and I want to make this easy for myself, so I'm going to change all of these so they have common denominators. And that way they'll all add together very easily. And the table is symmetric, so all I need is these different values here. So this will be 16 eighths plus 9 eighths plus 9 eighths plus 4 eighths plus 4 eighths plus 1 eighth plus 1 eighth plus 0. And that will go on, and I hope you see that your next four are actually going to be a mirror image of these. The next trapezoid will be 0 plus 1 eighth, and then 1 eighth plus 4 eighths, and so on, and it will continue. This actually frees up some room for me. I'm going to get rid of this table here now. It's no longer necessary. So now it's just a matter of adding together all these different areas. I can factor the eighth out in front too, which is kind of nice. This will be 132. 16 plus 9 is 25. 9 plus 4 is 13. 4 plus 1 is 5. 1 plus 0 is 1. This will be plus 1 plus 5 plus 13 plus 25 out of symmetry. Now if you add these all together, you're going to get, this is 38 plus 6, 44, plus 44. So you get 88 divided by 32. Both of those can be divided by 8, so you get 11 divided by 4, which is equal to 2.75. Now if you recall before, I said that the area under this curve is 2.66 repeating. So we are about 0.833 repeating off. And when we did our last estimation using the rectangles that were centered on each of the graphs there, we actually got 625, which was only about 4.16 or 0.04, and this is 0.08. Apparently my brain's a bit frazzled. So this is actually, we did the trapezoidal approximation. It was less accurate than when we did our centered rectangular approximation. This is actually not common. Usually if you do the same number of rectangles, you're going to get a better estimation using trapezoidal approximation. But ultimately, because we're still doing approximation, it's not completely perfect here. Another thing worth pointing out is this was actually bigger than what we were supposed to get, whereas our other approximation we did in the last lecture was smaller. And I hope it makes sense to you why that is the case, or at least why it's bigger. If I erase this here so I have some room to draw, we'll draw the graph again here really quickly, and I'm going to over accentuate the curves here. We draw our trapezoids, it's always going to be going above where it actually is in the curve here. Another thing worth pointing out too is in the situation if we had a graph that looked something like this and then we did our trapezoidal approximation, we would get bigger when it's curving this way, but we actually get an underestimate when it's curving this way. So just know all the different demons of your different approximations, but we're going to learn how to find the exact area soon enough, so that's ultimately the best way to go.